Right, in this video, we're going to talk about how to determine the number of solutions a system of equation has. And essentially, you have three choices. You're either going to have one solution, infinitely many solutions, or none. None is when your lines are parallel. So if you have parallel lines, that's your mathematical way to write that, you have no solutions. Now, parallel means they have the same slope. If they have the same slope and same y-intercept, they're technically the same line. So you're looking at when you have the same line. And then so if they're not parallel and they're not the same line, they have one solution, which means they intersect at one point. And that's how long lines work. So this one here says, how many solutions does the system of linear equations have? Use the drop-down menu to explain. So here we have y equals 3/4 x and y equals 4/3 x. So our slope is not the same. So they're not parallel. And since our slope is not the same, they're not the same line. And that means that they have to have one solution. So exactly one solution because the slopes of the equation are different. So the lines will intersect at one point. And again, you can see not intersect at all, intersect at one point, or both be the same line. And we can clear this. All right. So here's another. Which system of equations has infinitely many solutions? So this looks like, okay, this isn't that hard. But if you look at the equations, based on kind of that first example, what you have to do here is you have equations here that are not written in slope-intercept form. So you have slope-intercept form, y equals mx plus b. And what you need to do is you need to take equations that are not written in slope-intercept form and write them that way. So in A, you have 3y equals negative 5x plus 7. You need to use properties of algebra, like your algebraic principles of inverse operations, and doing the same thing to both sides to write this in slope-intercept form. So to do that for this, you divide both sides by 3, and you get y equals negative 5/3 x plus 7. Now, that's the first one. The second one, 3x equals negative 5y minus 7. So this one's a lot harder to get into slope-intercept form. First thing I would do is I would add 7 to both sides. So I have, let's write it up here, 3x equals, no, sorry. So I add 7 here. 3x plus 7 equals negative 5y. And these will cancel out. And then I divide both sides by negative 5. So I end up with negative 3/5 x minus 7/5 equals y. This should be minus plus 7/3. This is not the same. So they're not exactly the same, so it's not infinitely many solutions. You do the same thing for all of these examples to calculate the solution. I am not going to go through and do that for all of these. This is just kind of a sample. Next, which of these has no solutions? So again, you set up the same thing, but in this case, you're looking for parallel lines. So again, I'll just take A, 3y equals 1 plus x, and the other equation is y equals negative 2x plus 5. So you already know here, my slope is negative 2. In order for this to have no solution, you need a different y-intercept, so they cannot be the same line, and you need a slope of negative 2. Well, if I divide both sides by 3, y equals 1/3 plus 1/3 x. So my slope is 1/3. This is negative 2. They have a solution because I have a different slope. So this is wrong. That's the wrong answer. And you just need to take each one of these, put all the equations into slope-intercept form. This one they already are, so you should be able to quickly eliminate this. Negative 3, negative 3/4, they're different slopes. So this is wrong, and you have to go through and put these ones into slope-intercept form. y equals mx plus b. That's going to be the most amount of your actual work for these types of problems. If you have a problem where it says each equation in a system of linear equations has the same slope, what are the possible solutions the system could have? So if each equation has the same slope, they could have no solution or infinitely many solutions. Like that is your answer. And that's because it doesn't tell you about their y-intercept. If they have the same slope and the y-intercept's the same, they're the same line. If they have the same slope with different y-intercepts, they're parallel lines. And so they'd have no solution or infinitely many. You also run into problems like this, where Surrey makes $15 per hour and gets a weekly bonus of $25. Juan makes $14 per hour and gets a weekly bonus of $50. Is it possible for Surrey and Juan to make the same amount of wages, Y, by working the same number of hours, X? Use the drop-down menus. This is where you want to write a system of equations, so you have to go through the whole process of writing an equation. Y equals, so the X is the number of hours, Surrey is 15 per hour, 15X, whereas Juan is 14X, right? So we have different slopes, and gets a weekly bonus of 25, plus 25 for Surrey, and Juan is going to be plus 50 here. So per hour means times X, so that's 15X, 14X, weekly bonus of 25 plus 25 and plus 50. And then the question is, how many solutions would they have here? Well, it is possible. They have different slopes, so it is possible because the slopes of the equation are different, so the system will have one solution. Next, and we can submit it, and hopefully we have at least the 3 we answered right. We didn't actually answer those 2, and so that's good. All right. So we've looked at the general idea of this. Now I want to look at graphs, and specifically I want to show you some really cool tricks with graphs. So it says choose the graph that solves the system of equations. So when I look at these graphs, you're basically looking for which one shows these 2. And on a graph with a system of equations, you want to look for the one that actually has, you want to look for the intersection point. So when I look at this and I see like this point here, like that, this doesn't make any sense. So it's probably not B, all right? This one shows, again, this point over here. That's not the solution. So I'm guessing these two were wrong. So it could be this one or this one. And how do I know which one solves it? Well, which one graphs these 2 lines? Luckily, they're already in slope-intercept form. Y equals mx plus b. The slope of this first line is 2. And with a y-intercept of -6. So I look, and this looks like our y-intercept is the origin. This one looks like I have a y-intercept of -6, so that could be this line. So it could be C. This one here, -4 with a y-intercept of +3. So there we go, y-intercept +3. So it's probably C. That's where I would go, is this one here. And none of the other graphs, but this graph here looks like it could be it. Because it does have those things, right? The problem with this one is that this point here looks like it's off. So I'm going to go with C would be my correct choice there. Now here's one where it gives us the graph. We don't really need these equations because it gives us the graph, right? We just look, it says the graph solves the system, enter the solution. So the solution is just this coordinate, 1, 2, 3. So 3 is the x coordinate, comma 1, 2, 2 is what I put in there, right? And there's another way to do this though, because electronically, normally you might have paper and pencil, but electronically there's another way to do this. If you go to this website called desmos.com, and this /calculator is where you really want to go, this will graph all the stuff for us. If I literally come in here, you probably could just copy and paste this actually. If I right click copy, right click, maybe Control V is what works. Yep, paste. So now this line is graphed. And then I can come in here, select this line, Control C, here Control V, and I have this. And once you have them both here, you can actually see that it highlights this 3, 2. That's what I came up with, 3, 2. This graphs them for us and even highlights the intersection point. It also shows us the x-intercept, the y-intercept. If I click on the blue line, you can see the y-intercept there. You can click off here, and that could actually potentially help us figure out the slopes and mx plus b form, even though neither one of these is in slope-intercept form. over here on the left. So Desmos is a huge thing. Remember, this desmos.com/calculator is where you want to go, and you can actually graph and figure out the solution just by looking at where they intersect. Or you could graph lines that don't intersect, right? So say, for example, you have some lines that don't have a solution, like these ones here. This graph solves the system of equations. What is the solution to the system? Use the drop-down menus to explain your answer. So this system has no solutions because the two lines are parallel, and you can see they would never intersect. And you have these two graphs. Come over here and clear these out. I can copy, Control-C, Control-V. It looks to be working. I don't know if this will work with fractions. Let's test it out. Control-C, Control-V. Yeah, it did not work. So we do have to type this one out. Y equals -2/3. Now I have to hit the arrow key over. X plus 1/3. X plus 1/3. And so you see, look, there's no intersection point on these two lines. You can use your mouse wheel here, scroll out. You can still see there's no intersection. They're parallel here. What you could do with this one is convert it to slope-intercept form. So you could then write another parallel line. Or you could even, like, say I have a problem, which you will have a problem that asks you to come up with a parallel line. You can just do y equals m. So my slope needs to be -2/3 x, right? And then my b just needs to be something else, +7, whatever. Right? I literally could just change this b value and continually write parallel lines that would be different. So now I need to come up with another parallel line. Y equals -2/3x plus 8. Look, two different parallel lines. Yay! That's that. That's all I'm going to show you in this video. I know it's kind of long, but yeah, you want to use Desmos. You want to look at how many solutions there are based on these equations. You could even write, you could test, and if the lines overlap, you can see that they are equal. I guess that's the last thing I do want to show you. Y equals -2/3 x plus 8. And you can actually turn off these by clicking here. And now I just have these two, and you can see this one goes right over top of it. Or if I click on the other one, it shows they're the exact same line. So that shows infinitely many solutions there. And if I put this, these show the other ones that have no solutions in these systems. The end. Thank you.